test if sequence f and x f nx is equal to nx square for nx is where 0 is less than x is less than 1 converges uniformly to f of x is equal to x on closed interval 0 is less than x is less than 1. Solution here f and x is equal to nx square upon nx plus 1 where 0 is less than x is less than 1. So f of x is equal to limit n tend to infinity f of nx is equal to limit n tend to infinity n of x square upon nx plus 1, dividing numerator and denominator by n. So limit n tend to infinity x square upon x plus 1 upon n x square upon x plus 0 is equal to x square upon x equal to x. Thus the sequence f and x converges pointwise on 0 is less than equal to x is less than equal to 1. The limit of the function of f defined by f of x is equal to x 0 is less than equal to x is less than equal to 1. Let epsilon is greater than 0 be given, and then for 0 is less than equal to x is less than equal to 1 we have f of nx minus f of x is equal to nx square upon nx plus 1 minus x is equal to nx square minus nx square minus x upon nx x plus 1 is equal to minus x upon nx plus 1 is equal to x upon nx plus 1 is less than epsilon if nx plus 1 is upon x is greater than 1 upon epsilon, that is if n upon n plus 1 upon x is greater than 1 upon epsilon, that is if n is greater than 1 upon epsilon minus 1 upon x, but for x such that 0 is less than equal to x is less than equal to 1 we have 1 upon epsilon minus 1 upon x is less than equal to 1 upon epsilon minus 1. Thus if we choose n is equal to 1 upon epsilon minus 1 we have n is greater than 1 upon epsilon upon minus 1 upon x for all n is greater than n. Hence given epsilon greater than 0 there exists n equals to 1 upon epsilon minus 1 depending only upon epsilon not on x, such that f of nx minus f of x modulus is less than epsilon for n is greater than capital N. So for all values of x such that 0 is less than x is less than 1, hence f of nx converges uniformly to f of x equals to x on 0 is less than equal to x is less than equal to 1.